Hi guys, welcome to week 2 of remote learning. I just really hope that everybody's doing okay and that you guys are all well. If I can help with anything or help you guys out, please make sure you're reaching out, telling me what you're stuck on, what you need help with. I'm super available and I just really am looking forward to helping you guys out. Okay, so this lesson is going to be on us using our skills that we have so far, like dividing polynomials, being able to factor or use the quadratic formula in order to help us solve polynomials. So I have the steps written out here, so we're going to walk through 2 examples, and then your homework is going to be to do practice on finding the solutions to problems that are pretty similar to this using your guys' division, okay? So here's your first one. So it says, remember, we can solve any quadratic by either factoring or the quadratic formula. With higher order polynomials, this is not so easy. So higher order just means higher degree. So whenever it's not a quadratic, we have to do a lot more to be able to solve it. Okay, so here's the first step. Your first step is to solve, in order to solve the polynomial, is to find a root with your calculator. So we're going to start by plugging this equation into our calculator. So I'm going to move this over here. Okay, so we're going to go to y equals, and we're going to plug those in. Okay, so x to the 4th minus x cubed minus 5x squared, plus 3x plus 6. Okay, so what we're looking for is we're looking for a root. Remember, root is an x-intercept. So it looks like it maybe crosses at -2 or -1 and +2, but a really easy way to figure out where it super nicely crosses is by looking at the table. So remember, roots or x-intercepts have y equal to 0. So we're going to just go to our table and we're going to try to find where y equals 0. So I can see right here that 2, 0, is an x-intercept, and then let's just scroll up and see if we can find another one. So let's see. Oh, right there. So -1, 0. So we have 2 roots that we know, -1, 0. So what we're going to do is we're going to start by just using one of them. So find one real root with your calculator, and then we're going to write the root as a factor. So if 2, 0 is my x-intercept, remember, to get the factor, we just switch the sign. So x minus 2 is the factor that goes with it. So now what you're going to do is you're going to take this polynomial and you're going to divide by this factor. Now, since it's a factor, it should divide in evenly. So basically what we're doing is we're taking this polynomial and we're dividing by the factor that we know should go in nicely because it is one of the solutions or one of the roots to this polynomial, okay? So let's divide. So what we do first is we put this x minus 2 on the side over here. So this becomes x minus 2. And then we take the highest number or highest degree, and that goes in the box right next to my x. And then that's just a pattern and a puzzle trying to figure out what works. So this box up here is what I'm going to multiply x by to get x to the 4th. So that means the top box, this has to be x cubed. So then I'm going to multiply these 2 boxes. This becomes -2x cubed. All right, so now I'm going to switch my highlighter here so we can see. So I needed -x cubed whenever I finished writing this thing out. So I'm already at -2. I need that to be a -1. So that means that these 2 boxes have to add up to be -1x. That means this has to be a positive x cubed. So that when I add those together, I get -x cubed. Okay, so then I can fill in my box. So x times this box up here has to be an x squared. So then this has to be a -2x squared. Okay, and then we switch again. So I need those to add up to be a -5x. So this box and this box, -5x. So I'm already at -2x squared. So I need -3x squared more. So those add up to be -5x squared. Then I have to do the puzzle again. So this has to be a -3x. So when I multiply x times that, I get -3x. And then this becomes a positive 6x. Okay, so then my x's need to be 3. I'm at 6x. So that means in the diagonal, this should be -3x. So then my top box up here has to be a -3. So if I multiply, this has to become 6, which works out nicely because that's what we should have added in. So we divided nicely, and we got this answer to be x cubed plus x squared minus 3x minus 3. So what we're doing at this point is we're trying to factor this thing by using division. So you have now said that this top polynomial is equal to x minus 2 times the answer that we got. Okay, so I know one of my solutions is at 2, 0, which makes sense because that's what we found up here. But I'm at a cubic polynomial, so I still can't solve this using methods that we know. So I have to do division one more time in order to get this down to a quadratic. Now we do have this x-intercept 1, 0, so we're going to do it again. So it says find another factor and divide the third degree polynomial above by the factor that you found. So we found the x-intercept negative 1, 0. So that means it has the factor x plus 1. And so now what we're doing is we're taking this cubic and we're dividing it by this polynomial. Okay, so x cubed plus x squared minus 3x minus 3 divided by x plus 1. Okay, x plus 1 goes over here. The first term, this x cubed, goes in the box right next to the x. So then x times, this has to be x squared, so that it becomes x cubed. Then when I multiply those boxes, this becomes an x squared. Okay, then I need my x squared to stay x squared. So that means this diagonal needs to be a 0x squared. So that when I add, I'm left with just my 1x squared. Okay, so then the top box up here, I like to keep my x's so that they make sense. So obviously this is going to be a 0, and then I need another x, so that if I did x times x, I get the x squared. And then I do this, so 0 times 1, this would be a 0x, and I just include the x so I keep track. Okay, so now I know my x's have to add to negative 3. So if this is 0, that means this diagonal has to be a negative 3x. So then this top box has to be a negative 3. So then the bottom's going to be a negative 3, which divides nicely because that's what we ended with, and it should, because we're just trying to factor out that original polynomial. Okay, so here's what we've gotten as our answers. So we've now taken this polynomial and divided it and broken it up. So what we got is we've now said this first original polynomial is going to be equal to x minus 2 times x plus 1, because that's what we were dividing by here to break this one up. And now our answer that we have left over is this x squared plus 0x minus 3. So this whole entire thing factored would get us back to this original polynomial. So now what we have to do is we just have to solve for all of the real and complex roots. That means I just need to solve this for x if this were equals to 0. So let's just set each of those factors equal to 0 and solve for my x-intercept. So I'm going to ignore that because that's just 0. So if I solve here, I have an x-intercept at 2. So I have 2 comma 0 is one of my solutions, which makes sense because we found that above, right? And then we've got, oops, subtract 1, so this will be negative 1, which again we found, negative 1, 0. Those are the real x-intercepts. And now for this one, we're going to solve. So I'm going to add 3. So I got x squared equals 3. Take a square root. And then remember, when we do square roots, you have to put that plus or minus in front. So the square root and the squared cancel over here. So x equals plus or minus the square root of 3. So then my other roots are going to be the positive square root of 3 comma 0 and the negative square root of 3 comma 0. So this guy was a degree 4. Our original polynomial up here had x to the 4th. So that means when I finally solve this out, I should have 4 completely different answers. So these are going to be the x-intercepts or the solutions to that original polynomial. Okay? All right, we have one more example, and then I'm going to let you guys just go practice and ask some questions. Okay, so first step, I give you the polynomial. It says find one real root with your calculator and write the root as a factor. So notice this is a degree 3. So I only need to do division once in order to get this down to a quadratic that I can solve. So that means I really only need to find one real root. So let's move this over here and plug it into our calculator and see what we get. So x to the 3rd plus 3x squared plus x minus 5. Okay, and then you can go to the graph and look, so it looks like it goes through +1, but I always double check with the table. So yeah, it goes through +1, 0, because remember, x-intercepts have y equal to 0. So the x-intercept is +1, 0. So that means the factor here is going to be x minus 1. Okay, and then that's all you should need your calculator for. And now we're just going to go solve this thing out. So I know what I'm doing next is I'm taking this x cubed plus 3x squared plus x minus 5, and I'm dividing by x minus 1. Okay, so this x minus 1 goes over here. My highest degree, this x cubed, goes in the box right next to x. And then I just start solving. So let's see, this top box has to be an x squared. This box would have to be a negative x squared. And then I know my diagonals are going to have to add up to be 3x squared. So it's at negative x right now. So that means this one would have to be a positive 4x squared to make that work. So then the box above it has to be a 4x. This has to be a negative 4x. Okay, then diagonals again. So I know negative 4x plus this box has to be a positive x. So that means my diagonal has to be a 5x. The box above has to be a 5, so this has to be a negative 5, which works nicely because it should be. This should always divide evenly if this factor is going to be a real solution to it. Okay, so here's what we got. In this division, we now have the answer of x squared plus 4x plus 5. So what we did is we wrote this original polynomial, this x cubed plus 3x squared plus x minus 5 is equal to what we divided by times the answer. So we're breaking this up into what the solutions are, okay? So then now this last one just says solve the quadratic and list all of the real and complex roots. So I'm just gonna do it over here. So I know if I solve this, it's gonna be equal to 0 because that's where we're finding our x-intercepts. So this first one, solve for x, this gives us x equals 1, which we know we have an x-intercept at 1, 0. Okay, this other one is not so nice. So when we're solving this quadratic, we have to use the quadratic formula because it's not factorable. Nothing multiplies to 5 and then adds to 4. So we're going to plug it in our quadratic formula. Oops, not the highlighter. So x equals negative b, so negative 4, plus or minus the square root of b squared minus 4ac all over 2a. And then we're going to simplify. So negative 4 stays negative 4, plus or minus 4 squared becomes 16. Negative 4 times 1 times 5 becomes negative 20. Divided by 2 times 1, which is just 2. Okay, we're going to keep going. So negative 4 plus or minus the square root. 16 minus 20 is negative 4 over 2. And then we do know how to simplify that. So the square root of negative 4, remember this breaks into the square root of negative 1 times 4. The square root of negative 1 was I, and the square root of 4 was 2. So this becomes plus or minus 2I over 2. And then we're allowed to divide both of these by the 2 in the denominator. So negative 4 divided by 2 becomes negative 2. And then 2 divided by 2 just becomes 1. So this is just an I, and that's what x equals. Okay, so then we've got real solution, or real root, is going to be 1, 0. And then our complex roots, because those have the I, which is the imaginary part, are going to be negative 2 plus I, 0, and negative 2 minus I, 0. So these are the x-intercepts of these two. So you have the positive and you have the negative. Now again, let's go back to what we talked about before. We have 3 solutions, 1, 2, 3. So even though they're complex with imaginary parts, they're still solutions. And then this was a degree 3 polynomial. So I should have 3 answers at the end of this thing. Okay, so then the very last thing we're going to write down is just a definition, and then you guys are just going to go practice. So the fundamental theorem of algebra, it says a polynomial function of degree n has n solutions for the equation f of x equals 0. So if I have like x to the 5th plus 5 equals 0, since this is a degree 5, this should have 5 solutions, whether they be real or complex. So the degree of your polynomial tells you how many solutions you should have at the very end of this. Okay, guys? So your steps, you plug your equation in, Find a root, write the root as a factor, do division until you get yourself down to a quadratic, and then you're probably going to have to use this quadratic formula to solve because there's a good chance this isn't going to be nice. If you get to this quadratic and it's factorable, please factor, and then you're just going to list out all of your guys' solutions, okay? I hope you guys are doing good. Please reach out if this is too much, if you're confused on anything, if you need help. And I just want you guys to know that I really, really miss you, and I wish that we were in my classroom instead of learning this way, but we're making the best of it. All right, bye guys, I'll see you later.